So far in this unit, you have found we've taken a set of data, a set of numbers. They might be basketball scores, they might be quiz scores, they could be any set of numbers, okay? And we have different ways of measuring them. One that you've learned is the mean or the average. 2 is the median. 3 is the range. 4 is the mode. You've learned all of those things to describe a set of data. We also did the interquartile range. Okay, that was something else we found. It measures data. This one we're going to do today is called the mean absolute deviation. MAD. MAD. Okay. The mean absolute deviation measures how consistent or how tightly packed the set of data is. Okay? So the smaller the MAD, the smaller the mean absolute deviation, the more consistent the numbers are. Take quiz scores, for example. I have these quiz scores up here on a social studies quiz. We had a 9, we had a 10, we had an 8, we had a 10, we had a 7, we had an 8, and we had a 4. Okay? We are going to find the mean absolute deviation of that of that set of numbers. I will tell you this. If all of the numbers, if all of the scores are very consistent, meaning it stays all close to the same, like 7, 8, 9, 7, 8, 8, 7, the smaller the mean absolute deviation is. If I have numbers all over the place, let's say I have a 10, and then I have a 2, and then I have a 7, and a 4, and then a 7, and then a 1, and then a 10, and a 0, that means those numbers aren't consistent. They're all over the place, right? My mean absolute deviation is going to be bigger. Watch. 3 steps to finding it. 3 steps. So I suggest you write these 3 steps down. You too. I don't want to run into the same situation we ran into yesterday. Okay? Step number 1. Find the mean of the data. Step number 1 is find the mean. So these right here, we got our what is it? How many numbers do we have? 7 numbers. Our 7 quiz scores. How do we find the mean? What do we do? Yep, you add them all up and divide by how many there are. So we're going to add all these up. We got 9 plus 10 plus 8 plus 10 plus 7 plus 8 plus 4. Anybody add them up yet? It's 56. Okay? Then we have to divide by how many? 7. What's 56 divided by 7? 8. So my mean is 8. That's easy, right? Next part's even harder. Step number 2. You find the distance each data point is from the mean. Meaning, if it was on a number line, how far away is it? How far is 9 from 8 on a number line? 1. How far is 10 from 8? 2. 8 from 8? 0. 10 from 8? 2. 7 from 8? 1. 8 from 8? 0. 4 from 8? 4. Told you that was harder, right? We had a number line. How far away is it? That's it. That's step number 2. Step number 3. Very simple. Take all of these and find the mean of those. So we add all of these up. 1 plus 2 is 3, plus 2 is 5, plus 1 is 6, plus 4 is 10. And divide by the number of numbers. If you have a calculator, it's super easy. 7 goes into 10, what? 1 minus 7 is what? 3. Add a 0 here, bring it down. 7 goes into 30 how many times? We'll stop there. We're going to round this off to 1.4. So my MAD, my mean absolute deviation, 1.4. Or I shouldn't do that. I should be about. That little squiggly equal sign means about. So to do this, it's 3 simple steps. It's nothing new. It's just you found mean before, right? So step number 1, you find the mean of the data. Step number 2, you figure out how far each one of those data points is away from the mean. And then you find the mean of that number. And then you got your mean absolute deviation. Can you see how if these numbers were all bigger, meaning if each one of these was farther away from the mean, how it measures how consistent things are? Because let's say this wasn't a 9, let's say that this was a 4. This would be 4. That means that this number would be bigger. And then if this wasn't a 10, let's say this was a 12. This number would be bigger. And the bigger number, the larger numbers we have in here, the larger our average was going to end up being, or the larger our mean is going to be, and that means that we are less consistent. So the larger the mean absolute deviation, the less consistent we are. As a basketball coach, I could use this to figure out how consistent my players are. If I had a player that consistently scored, let's say 10 points one game, next game they score 12, next game they score 11, next game they score 13, next game they score 9. And I found the mean absolute deviation of that. I would figure out that, hey, that player scores, their mean absolute deviation is going to be a really small number. They're very consistent. Whereas if I had another player that scored one day, scored 2 points, and the next day scored 30, and the next game they maybe scored 15, and the next game then they scored 1, and then all of a sudden they blew up and went off for 40, that would show their mean absolute deviation would be a very large number, which shows that they are not a very consistent scorer. You understand that? Make sense to you? Okay, because it's going to be bigger. All right. I have a worksheet for you. It's a review for the first 5 problems. And then the last 3, you have to find this. Okay?